So the idea is to use these operations that we just saw to transform the original system into something that looks like this. But that's not really what we'll end up doing. So let's just do an example where you see what I mean. And I'm honestly pretty sure that you know how to do the elimination method already. This is the example we just did. Do you remember what the solution was? I remember that x was 2. Oh my, what did I just do? I skipped a page. No I didn't. We saw that x was 2 and y was 1. We'll do the same thing, except this time we'll use elimination. So then, the way you approach this is by deciding which variable you want to eliminate. Normally, you choose the one that has a coefficient of 1 in either equation because we're going to be multiplying or dividing by something. So you want to pick the variable that has the easiest value to manipulate, and 1s are the easiest number. So looking at this equation, 4x plus y is equal to 9, 3x minus y is equal to 5. Looking at the coefficients on the y's, you've got positive y in the top equation, negative y in the bottom equation. So honestly, eliminating y will be very easy because if we just add these two equations together, the y will drop out. So we're going to eliminate y. Compare the coefficients of the chosen variable. Multiply one or both equations by some multiple, a constant, so they have the same coefficient but opposite sign. So again, you are looking at the coefficients on your y's. If these two are not the same number, in this particular problem, the coefficient here is 1 and here you have negative 1. So they are already the same number but opposite sign, so we actually don't need to do anything. We can simply add these two equations together. So 4x plus y is equal to 9, 3x minus y is equal to 5, and we can just add these two equations together, and when you do that, the y's add up to 0. So they're gone, and you end up with 7x is equal to 14. Then divide both sides by 7, and we get that x is 2. This is starting to look familiar, right? Well, I guess I already did this part. I knew I ended up in the wrong place. Alright, so step 4, that should have allowed you to solve for one of the variables. We got that x was equal to 2. Now we need to find the other variable. So pick whichever equation you like. I think that I like the one that has a positive y, so 4x plus y is equal to 9. 4x plus y is equal to 9 is the one I will choose. I substitute in the value 2 for x, and then that will allow us to solve for y. 8 plus y is equal to 9, so y is equal to 1. Things don't always go this smoothly when using the elimination method. There are some kooky things that can happen, and we'll address those now. Things to look out for when you're using the elimination method. One of the things that can happen is that after you perform your addition and subtraction, which is you can get 0 equals 0. Think about that. This means that everything falls out. Everything on the left adds up to 0, everything on the right adds up to 0, everything drops out. 0 does actually equal 0. It might look strange, but it's true. When you get 0 equals 0, you have to conclude that the system has infinitely many solutions. Oops. I can't spell infinitely. When this happens, you can represent all the possible solutions in terms of y, or whatever the rightmost variable is. We call y the parameter. And I will probably skip the parameterizing part. Now, secondly, if after performing an addition or subtraction, the second odd thing that can happen is you get 0 is equivalent to a non-zero value. Well, that shouldn't make any sense. That's not true. 0 does not equal a non-zero value. See what I mean? 0 equals, let's say that this pound symbol here is a 4. 0 does not equal 4. When that happens, you have to conclude the system has no solution. We will look at an example of each of these. So let's solve this system. 2x plus y is equal to 6. 4x plus 2y is equal to 12 by elimination. I'm not sure if I'm leaving space here or there. Yeah, we'll have to make space at the bottom here. So now the first step is, again, select which variable you would like to eliminate. I make the selection based upon the lower coefficients. So I have, for x, I've got 2 and 4. That doesn't look so bad. But y looks even better because we have a 1 and a 2. So I'm going to eliminate y. Eliminate y. So now, to eliminate y, we actually have to do some work this time. We want the coefficient on y to be the same value but opposite in sign. To do that, I would need the coefficient in front of this y to be a -2 so that it would cancel out with this +2. That means I'm going to multiply this top equation by -2. And I'll number these again to make this a little easier. So I'm multiplying equation 1 by -2. Doing so, I will get -4x minus 2y is equal to -12. The second equation, so this is equation 1, carrying down equation 2 that is not getting changed at all. I'm just writing 4x plus 2y is equal to 12. Then we add these two together. -4x plus 4x is 0. -2y plus 2y is 0. -12 plus 12 is 0, which means 0 is equal to 0. That means you have infinitely many solutions. This one will be a little bit different. I'm guessing you're going to guess that we'll end up with no solution. So once again, we have to select which variable we would like to eliminate. Looking at the coefficients on x, we have 2 and 4. That looks doable. But since these numbers are even smaller, 1 and 2, that looks even better. So again, we'll eliminate y. To do that, again, this is equation 1. This is equation 2. I'm going to multiply equation 1 by -2. So when I do that, equation 1 becomes -4x minus 2y is equal to -12. Equation 2 has not changed. It's still 4x plus 2y is equal to 8. Adding them together, -4x plus 4x is 0. -2y plus 2y is 0. -12 plus 8 is -4. We get that 0 equals -4, which is false. 0 does not equal -4. This means there is no solution to this system.